Welcome to Nimu's World. It's me Nimesh Naik. Today I am discussing CSIR net questions December 2018. Topic complex analysis. It's a part C question. Question: which of the following statement are true? Option number 1, tan z is an entire function, and option number 2, tan z is a meromorphic function on C, and option number 3, tan z as an isolated singularity at infinity, and option number 4, tan z as a non-isolated singularity at infinity. So in this question we want to find the correct options. So in first option we have given that tan z is an entire function, so we want to know what is an entire function. And in option number 2, tan z is a meromorphic function, so we want to know what is meromorphic function. So for solving this question we want to know some basic definition. So first I define some basic definition. So first, entire function, and if f is analytic at every point of C, then f is called an entire function. That is, a function f is said to be entire if it is analytic at every point of C. And the next definition, pole. An isolated singularity z naught belongs to C of f is a pole of f if limit z tending to z naught f of z is equal to infinity. Next definition, meromorphic functions. Let f be an analytic function in a domain D except some points in D. If f has only poles as singularities, then f is called a meromorphic function. That is a function which have only poles as singularity, then we called that function is meromorphic function. Now we are going to our question. Let f of z is equal to tan z, and we know that tan z is equal to sin z by cos z, and f is not defined when cos z is equal to 0. So the points at which f is not defined are given by cos z is equal to 0, which implies that z is equal to 2n plus 1 pi by 2. That is, cos z is equal to 0 only when z is equal to 2n plus 1 into pi by 2, where n belongs to z. So there exist countably many points at which f of z is not analytic. That is, we have said that f of z is equal to tan z is not analytic in the entire complex plane, because we have f of z is equal to tan z, and tan z is equal to sin z divided by cos z, and cos z, the singular points of f of z are given by cos z is equal to 0. So cos z is equal to 0 only when z is equal to 2n plus 1 into pi by 2, n belongs to n. So there exist countably many such points. Therefore f of z is equal to tan z is not analytic in the entire complex plane. Now we are going to our option, our first option, which says that tan z is an entire function. But we have given that f of z is equal to tan z is not analytic at a countably many points. Therefore our tan z is not an entire function. Therefore our first option is wrong. And also the isolated singularities of f of z is equal to tan z are z is equal to 2n plus 1 into pi by 2, where n belongs to z, because at z is equal to 2n plus 1 into pi by 2, f of z is equal to tan z is not defined. And we also know that all the isolated singularities are poles, because at the point limit z tending to 2n plus 1 pi by 2 f of z, which is equal to limit z tending to 2n plus 1 into pi by 2 tan z, which is equal to infinity. Therefore we can say that all the isolated singularities are poles. So we can say f of z is equal to tan z has only poles as a singularity. So f of z is equal to tan z has only poles as singularities means that f of z is a tan z. F of z is equal to tan z is a meromorphic function, because the definition of meromorphic function is a function which has only poles as a singularity. Therefore we can say that f of z is equal to tan z is a meromorphic function. Now we are going to our second option. Our second option is say that tan z is a meromorphic function on C, therefore which is a correct statement. Therefore our second option is correct. Before going to our third and fourth option, we want to know some notes. So note number 1, limit point of 0 is an isolated singularity, and note number 2, limit points of poles is a non-isolated singularity. And next we want a result singularity at infinity. So result z is equal to infinity is a pole of order n of an analytic function f if and only if z is equal to 0 is a pole of order n of f of 1 by z. Okay, now we are going to our third and fourth option. So we want to verify the singularity of f of z at z is equal to infinity. So for that we want to check the singularity of f of 1 by z at z is equal to 0 by using this result, because this result is saying that z is equal to infinity is a pole of order n of an analytic function f if and only if z is equal to 0 is a pole of order n of f of 1 by z. Now we are checking the singularity of f of 1 by z at z is equal to 0. Now we have f of 1 by z is equal to tan 1 by z, which is equal to sin 1 by z divided by cos 1 by z. Now the poles of f of 1 by z are given by cos 1 by z is equal to 0. So cos 1 by z is equal to 0 means that 1 by z is equal to 2n plus 1 into pi by 2, n belongs to z. That is cos cos z is equal to 0 only when z is equal to 2n plus 1 into pi by 2. Therefore here we have 1 by z is equal to 2n plus 1 into pi by 2 where n belongs to n, which implies that z is equal to 1 by 2n plus 1 into pi by 2. That is z is equal to 1 by n plus 1 by 2 into n. And also we know that z approaching to 0 as n tending to infinity. That is we have get f of 1 by z is not defined, z is equal to 1 by n plus 1 by 2 into n, and this tending to 0 as n tending to infinity. Thus we have said that z is equal to 0 is a limit point of the poles of f of 1 by z. That is we have get the poles of f of 1 by z are z is equal to 1 by n plus 1 by 2 into n where n belongs to z, and which tending to 0 as n tending to infinity. Therefore we have said that z is equal to 0 is a limit point of the poles of f of 1 by z. Then by note number 2 we have said that z is equal to 0 is a non-isolated singularity of f of 1 by z, because the limit point of poles is a non-isolated singularity. Therefore we have get z is equal to 0 is non-isolated singularity of f of 1 by z, which implies that z is equal to infinity is a non-isolated singularity of f of z. That is we have get z is equal to infinity is a non-isolated singularity of f of z. Now we are going to our third option, which says that tan z has an isolated singularity at infinity, but we have get here z is equal to infinity is a non-isolated singularity of f of z. Therefore our third option tan z has an isolated singularity at infinity is a wrong option. And our fourth option, which says that tan z has a non-isolated singularity at z is equal to infinity, because here we have get z is equal to infinity is a non-isolated singularity of f of z, since it is our fourth option is correct. So the correct options of this question is option number 2 and option number 4. Okay, thank you. If you like my video, please subscribe my channel and also share and like.